You've probably looked up into the night sky and asked yourself how it got there, and you wouldn't be alone. Well, you may be alone in life, but other people wonder about the sky is what I mean. Unfortunately, the answer isn't so simple, and it's taken thousands of years for us to come to today's conclusion. 13.7 billion years ago, the universe was a tiny speck, a singularity known as a primeval atom. It would rapidly expand to form, over billions of years, the universe as we know it today. This is what is known as the Big Bang Theory, the most widely accepted theory of the universe's origins to date. But what actually happened? The Big Bang is a miraculous phenomenon that even to this day we do not fully understand, but scientists do have some predictions as to what happened during the initial expansion. Approximately 0.00000000001 seconds after the Big Bang, the quark era began. During this period, the universe began to take shape. Quarks, subatomic particles, began to form, and the four fundamental forces of the universe took shape. These are the gravitational force, electromagnetic force, and both strong and weak nuclear forces. 0.0000001 seconds after the Big Bang was the Hadron Era, a period in which the universe became cool enough for quarks to bind together to form larger subatomic particles such as electrons and photons. These would collide to form even larger particles like protons and neutrons. 3 seconds after the Big Bang, the lepton epoch occurred, and in this time, basic atoms would form. Hydrogen, helium, and lithium are among these. The elements that were formed were of a low atomic mass because it required greater temperatures than were currently available. From here to 300,000 years later, the radiation era occurred. In this time, the radiation and energy throughout the universe dominated it in its expansion. After this, and 100 million years after the initial Big Bang, stars began to form from the clouds of hydrogen and helium, called nebulae. These would eventually form galaxies, and 9 billion years after the primeval atom initially expanded, our solar system would form. With all scientific theories, there must be evidence to support it. Unfortunately for the Big Bang Theory, there is no shortage of this. The main evidence for the Big Bang Theory consists of the observable expansion of the universe, the presence of cosmic microwave background radiation, and the abundance of hydrogen and helium throughout the universe. Firstly, the expansion of the universe can be demonstrated through the redshifting of light due to a phenomenon called the Doppler effect. The Doppler effect states that as an object moves away from you, the waves it will emit will increase in wavelength, making sound appear lower pitched and light appearing to have shifted to the red end of the light spectrum, hence the name redshift. The opposite is also true. As things move towards you, it sounds high pitched and looks more blue shifted. Redshifting is how we know the universe is expanding, because from Earth, every galaxy except a select few appears to be moving away from Earth. The final piece of evidence for the Big Bang is the abundance of light elements, such as hydrogen and helium, throughout the universe. These are the first elements created during the Big Bang due to their simple atomic structure, low resistance to heat, and versatility when it comes to making stars and galaxies. The abundance of hydrogen and helium also allows us to model the rate at which the early universe expanded. If it had been faster, there would be more neutrons and helium throughout the universe. If it was slower, there would be less helium due to these neutrons decaying. The way we can tell that stars and massive celestial structures are made of hydrogen is the spectra hydrogen makes when observed through a spectroscope. Every element has a unique spectra when observed from a spectroscope, and we can see that the outside of a star is mainly comprised of hydrogen, along with certain heavy elements that give a star certain colors. The second piece of evidence for the Big Bang Theory is cosmic microwave background radiation. It is theorized that when the Big Bang happened, it filled the universe with a glow that still remains to this day. It can be detected from all points on Earth equally, provided you have a telescope powerful enough to detect minute quantities of microwave radiation. Cosmic microwave background radiation is approximately at 2 degrees above absolute zero, minus 271 degrees Celsius, which matches the average temperature of the universe, which is cooled from the distribution of heat as it has expanded over the 13.7 billion year period. Before the Big Bang Theory, solid state theory was the dominant scientific theory ascertaining to how the universe formed. Solid state theory was proposed in 1948 by Fred Boyle. It was suggested to follow the perfect cosmological principle that states that the universe is infinite in extent, infinitely old, and it will remain in this state forever. It falls under the belief that the universe is consistently dense and that stars form at the same rate as they die. However, cosmic background radiation disproves this, as you can see that the heat in the universe is not evenly spread throughout, suggesting that it is not in a steady state. Another theory as to the universe's origins is the geocentric theory. It states that the Earth is at the center of the universe, and that is why galaxies look like they are receding from us. This was disproven by Hubble's law, which states that the further an object is from Earth, the faster it is receding from us. Advancement in technology, such as more powerful telescopes and the ability to pick up more subtle radio waves, has led to the discovery of evidence for the Big Bang Theory. Georges Lemaitre, a Belgian astronomer, theorized that the movement of galaxies can be explained by the expanding universe. Edwin Hubble would later prove this to the scientific community through the creation of Hubble's law, which we previously explained, in 1929. Cosmic background radiation, one of the strongest pieces of evidence for the Big Bang Theory, was discovered by Robert Wilson and Arno Penzias on May 20th, 1964. It was discovered accidentally while they were studying other radiation throughout the universe. They thought it was interference in the signal, or something was wrong with the machine. Over the centuries, scientists learned more and more about the universe, but it is only within the last 100 years that we have truly learned about the correct theory of the universe to date. We have finally learned about the Big Bang. You're probably going to look up into the night sky and be like, so that's how that got there. You're still eternally alone, but now you know there are other people who ponder about the universe too. Through the discovery of the universe's expansion, cosmic background radiation, and the abundance of light elements, scientists have proven without a doubt, at least in the world's mind, that the Big Bang Theory is how the universe began.